Now, we looked over the macronutrients. Let's spend some time with micronutrients, like vitamins. Vitamins, they are essential in the diet in small amounts. All are carbon compounds with a wide range of physiological functions. And long before the reasons were understood, it was known that lime and other citrus juice cure scurvy. Involves weak muscles. English sailors used to be called limeys because they would bring along limes on board. It was also known that cod liver oil prevents rickets, soft bones. Eventually, it was discovered that these diseases are caused by deficiency in vitamins, which are organic molecules required in only trace amounts that must be obtained through the diet. Vitamins are a dietary necessity for humans because we do not have the ability to synthesize them. For example, you can avoid scurvy by taking sufficient amounts of vitamin C. Rickets, vitamin D. Vitamins can be classified as polar or nonpolar. Like dissolves like, remember this? So, some dissolve in water, like B's and the complex, the complex vitamins B's and the vitamin C, and some dissolve in fat. Nonpolar vitamins like A, B, D, E, and K. Remember, water is polar and fats are nonpolar. I think it'd probably be better to put an S there to emphasize the fact that fats are a huge group. So what happens? Well, vitamin C and all the B's will flush out in the urine, which is mostly water. So if you've ever taken a multivitamin and your urine turned bright yellow, that is excess B vitamins. It is very expensive urine. Now that's inconvenient or expensive or not wasteful, if you will. Get it? Wasteful. But it is important not to overdose in these nonpolars because these can be stored in fat and overdoses are possible. In fact, when the whole idea that vitamin A was this wonderful thing to avoid uh, aging, people did mega doses of vitamin A's, and you saw toxicity problems everywhere. Here they are. Now these again are the line drawings, and every time we see a curve, we've got carbon there, all right? Again, we are mostly looking at carbon, hydrogen, and oxygen. But we've got a little bit of nitrogen, nothing compared to proteins. Sometimes we get sulfur, okay? But I want you to think about the polarity of these. Vitamin A has this long non-polar chain. Vitamin B has these different elements here that give it a polarity. All right, give it a polarity. Remember, nonpolar means that the charges, the electrons, are balanced. Polar means you've got big differences in electronegativity leading to dipoles, where you've got two poles, a positive end of the molecule and a negative end of the molecule. Same is true for this is vitamin C, and it has oxygen sitting out here. And if you recall, oxygen has a very high electronegativity. And it has a dipole. The bonds have dipoles, and the overall molecule has a dipole. And we can skip all these, and these are available, but every one of the different vitamins helps us with different chemical behavioral or chemical reactions in our bodies. Okay. Now, vitamin D I do want to spend a second on because some people think that we get it from the sun. No, the sun promotes or provides the energy to allow chemicals in your skin to produce the D. It's not like the sun's up here and vitamin D rains down on us. You know, it's hard to understand that sometimes when they say you don't get enough sun, and you don't get enough sun in Ohio. So you are very wise to take a vitamin D supplement. Many of the other things, the other vitamins, no, we probably get them in if we eat a well-balanced diet, but a lot of people don't. Okay, vitamin E. And notice how many things are good for you that have vitamins in them. Fruits and vegetables. This is how the whole chapter started, remember, talking about the importance of eating well. Vitamin K. In the body, vitamin D is concentrated in the skin, liver, and kidneys. Vitamin A found in the liver and kidneys. The kidneys is a very fascinating place. We can get excess of both. And this is just kind of a leading one because that would tell you that they are fatty. You got a lot of fat in the liver and the kidneys. And there's a wonderful story about a guy who was lost in a blizzard with a dog team. He ate the dog's livers principally because they were so fatty and he needed the calories, and he lived through the blizzard, but about a month later he died because one of the symptoms of one symptom of vitamin A poisoning or overdose is skin sloughing off. I don't know if you'll notice that when they talk about retin A, which is a precursor of vitamin A, in skin creams, they'll say, well, your skin's going to peel. Well, if you take a lot inside, all your skin peels off. And he died. Now, which one vitamins do you like to need every day? How about the water-soluble ones? The water-soluble. Because you'll just flush them out. These are very rare because you store them in your fat. And these are water soluble, so they don't stick around. Do intermolecular forces of attraction play a role in our diet? You betcha. Unequivocally, yes. So remember what these were. These were like hydrogen bonding, dipole-dipole, like dissolves like. Excellent. Now, minerals are also micronutrients. They are even smaller amounts in your body. Their use is very complicated. The quantities are very small, but we've got 2, 4, 5 major ones. Right? Calcium for your bones, sodium, potassium, chlorine. That keeps your electrochemical balance in your body. There we go. Needed for proper neurological, muscular, and heart function. And we talked a little bit about electrolytes and the importance of electrolytes in your body back when we were talking about water. Macro or micro trace minerals. These are even smaller amounts. And you know, it is the iron in your blood that attaches to the oxygen, the O2 that you breathe in. Man, if you don't have that iron there, you would suffocate. So it's just one little iron atom at the bottom of your heme molecule, but without it, you're totally sunk. Okay? And your body uses all sorts of ones that you might even consider poison. Okay? Now this is just one last thing to understand. Look at the energy. I want you to appreciate that photosynthesis produces glucose. Okay? and the energy in from the sun. Okay, this is in the air, carbon dioxide and water. The glucose is used by the plant. We eat the plant. We eat the little creature that ate the plant. And then in metabolism, energy out to fuel our bodies. It is the circle of life. And a chemist can figure out exactly how many chemicals it'll take. Woo! And how much energy there is. Photosynthesis is endothermic energy in. And metabolism, when we chew everything up and eat it and make glucose, is energy out to our bodies. We can do that with these little energy in going up, metabolism energy out, but the products and reactants, product, they are the same. So this is what we eat. This is what we breathe. And this is the energy we collect.